So we've calculated our parity bit for this number here. And now let's say that we transmit it and something gets screwed up a little bit, right? One bit gets flipped. And let's say this is what we receive. Let's say we receive 1, 1, 1, 1, 0, 1, 1, 1, 0. So here's what we do. We don't really look at this bit yet. We instead take these bits here, right? We take our data bits and we compute what the parity bit should be. Right? We compute what the parity bit should be. And so I've got 1, 2, 3, 4, 5, 6, 7 ones. I have 7 ones. And so that means the parity bit should be 1 if we're using even parity. Parity bit should be 1. And then we compare our calculated parity bit to our received parity bit, and we see that they are not equal. And so therefore, this indicates an error. Right? This indicates an error. So that is one way to do it. The other thing is, since we know we're using even parity bits, we could just count up all the ones, including our parity bit. So we could see 1, 2, 3, 4, 5, 6, 7 ones, and say that, hey, this total number of ones across all 9 of these bits should be even, and it's not. And so that's another way that we could get an error or indicate our error. And so in this case, in this transmission, what would happen is this is our transmitter, right, TX, and this is our receiver, RX. What would happen is the receiver would just say, hey, there was an error. I don't know what was wrong, but I know something was wrong. Can you resend it? Can you repeat it? Is usually what would happen in this case.